Okay, good morning, student.
Good morning, sir.
Good morning, sir.
Okay, so we will continue our study. So today we will talking about, we will learning about actuator. Check. Okay. Okay, actuator is one of the important component in IoT development system. We need actuator, sensors, controller, and actuator. They will working together. In the last day, we already learning about controller. Controller means the brain of our IoT system. And actuator, like if we looking our body, our human body, actuator like hand, like leg. So it relate with action of uh, our brain decision. So in IoT, there are many type of actuator. You can see here, there are many type of actuator, such as a DC motor, then relay, solenoid valve, servo motor, stepper motor, and another, and so on. So the actuator is activated by mechanical system. For example, some actuator it drive by wine, not wine, air, air. And also there are another type of actuator, they driven by liquid. For actuator that drive by air or wine, we call it pneumatic system, pneumatic device. And the actuator driven by liquid, we call it hydraulic device. Okay, so there are three options for actuator. If we can find in the market actuator that driven by electric, driven by liquid, and driven by air. So pneumatic, hydraulic, and electric actuator. For example, we have three type of actuator type. There are linear actuator, rotary actuator, and electromagnetic actuator. Linear actuator means it makes motion in the straight line. For example, if you see this device, this is the actuator, linear actuator. So the motion will be right and left motion, not rotary motion, but they will straight line move. For example, from this point, they will move to the right side and move to the left side. We can use this actuator to push some type of things. For example, we want to push the beam or the bar or any type of things in industry. If we want to push these things, we can use linear actuator. So there are some mechanical system inside the motor. We call it how to say, gearbox. Gearbox. Gearbox means I think we can see here. Gearbox motor. So we call it gearbox. It makes reduction the power, reduction the speed, but it will increase the power of our motor. We call it torque. How to say? It makes it produces the torques. Torques. Torque. In Indonesia we call it torque, but I don't know in your country we call it torques. In English it's torques. So and the mechanization of this gearbox, it will make some power to motor. They generate the power to push everything, to everything. So in linear actuator, we will use this gearbox mechanization to produce some of the energy, some of the power to push everything. The another type of linear actuator also we will find in industry. Many type of actuator in industry, they use a linear actuator for push something and for the move of production device, production machine in industry. This is the example, example of linear actuator that are applied to many things, especially in industrial production part. For example, for material handling, or robotics, for food and beverage manufacturing, to filling the bottle, liquid the bottle, and for window automation, or for open and close the door. For example, we can see in the bus pneumatic door. I think you often see this type of the door. So the door is automatic, driven by pneumatic system, by linear actuator. So it can to open and close by using actuator. It's one of the type implementation of linear actuator. For the bus door system, you see here. Many of this implementation for the door, they use pneumatic actuator. They use the solenoid valve pneumatic actuator. It uses the air, the high pressure air, high air pressure for move this linear actuator. The another type of linear actuator also for material handling. If you can see here, this robot, they will make some motion to pick and place. For example, if you see the medicine industry, they use this robot, this mechanization to pick some of the medicine and place to the box or another place. They use a pick and place. So this is the linear motion also. Material handling is the vital component, vital machine in industry. Most of them, they use pneumatic linear actuator. The pneumatic linear actuator means this actuator driven by air, the high pressure air, the high pressure air. And in another example, we see here is a robotics actuator. Linear actuator can be installed on wheels, in the clamp arm, or in the leg of the robot. Because we need this robot to handling everything in industry. For example, for shifting, for lifting the car, or lifting the many anything in industry. So the linear actuator is usually used to clamp object to be moved to a certain point. So it is a linear actuator, yeah. So it is like our arm. So they will it will clamp or put. So from in the two sides, it will be clamping object, and it will move to a certain point. For food and beverage also, we use the linear actuator for packaging and for other process, for example, for filling the liquid to the butter. We also use the linear actuator. It's already we talking before. It's about linear actuator for window automation. It's same. Has similarities with the bus door system that we talking before. And the next is the rotary actuator. So it different with linear actuator. For this system, the motion is rotary, rotary. So it will move rotary, not linear. For example, we can use this type of the actuator in piping system. As far we know that in the many industry they use piping system for transfer one type of the liquid to another site, to transfer one liquid to the process in the next process, and many type of the process that we can find in industrial system. So it is a vital and it is the important actuator that many industry use for controlling a system. So there are there are two systems that we can find this device in industry. One is rotary actuator that can to open in two positions, 0 degree and 180 degree. So there is a actuator, rotary actuator, that it can only to move only in two conditions. It will be open or it will be closed. I mean, for this part, it will be open. Open means 0 degree. And it will be
Pwede niyo for 80. Pwede niyo
fully open. Sorry, fully open. So 180 degree. So 0 degree is the close, and 180 degrees means it's open, full open, 100%. And another type of this rotary actuator they can to move by our setting, by our controlling signal. It means it can to manage to open by ourselves. For example, we want to move, we want to open just 20 degree, for example, or we want to move just 30 degree, or we want to move 90 degree, for example. So we call it actuator, control valve. So we can to control, we can to manage the condition of this valve, the condition of this valve. Not only two conditions, but we can control by ourselves how many this gate will be open, because in the some process in industrial process, sometimes we need to open just 30 degree gate, 30 degree open, and sometimes we also need to open just for 60 degree or 5 or 50%, or we want to open 100%. So you can you will find there are two types of the valve or rotary actuator in industry. The another actuator is the electromagnetic actuator. Electromagnetic actuator work by utilizing the magnetic that's generated by electromagnetic force. Do you know that you can make some magnetic system using electricity? I think you have done to practical the electromagnetic in your senior high school, I think, because it is the mandatory material for senior high school. You have learning about electromagnetic, right? Electromagnetic. Do you have practice before maybe in your senior high school? You can make some magnetic, for example, this you can make a magnet by using, you give electricity in one of the plug or iron plate. You see, treating, treating. Or this covering the iron using sorry, okay, we call it copper. Is the copper that cover the iron, and in the end and in the front of this copper, we give electricity, DC electricity in this side and in the end side, and this iron will be magnet, will be a magnet. So we use this for the relay mechanization. So we use electromagnetic coil. So we have one plug, we have one iron, and we cover with copper, and we put this in here. In this position is the voltage, the positive voltage, and here is a negative voltage, and this part will be a magnet. So it is the concept for relay mechanization. Yeah, inside this device, inside these things, there are magnetic coil mechanization. Also here in solenoid relay, also we use a magnetic coil. This is a relay. We call it relay. Relay are electromechanical switch. So you know switch. This is switch. Switch means how to say? Switch. Yeah, this switch. I think you already know about this.
Yes, sir.
We call it switch. So it is the electromechanical switch. So we don't need to push these things. We can find this in our home, but the working principle is we need to push this type this area to make circuit to close and will be power our lamp. This is the mechanical switch, but relay is similar with this type of the switch, but we don't need to push using our hand. We don't need to push using our finger. We will replace our finger with electric signal. You know, this is the basic concept of the relay. Relay is replace this type of the switch, mechanical switch. So we don't need to push with our finger, but we can to push by electric signal. How to push this relay? How to push this switch? We use the mechanism. We use the electromagnetic mechanization that we talking before. So inside this device, there are the coil. This is the coil. So we just trigger by in this side. We give electricity voltage, and this coil will be a magnet, and it will how to say? It will pull this iron, this side armature. We call it armature. It will be pulled here, and it will connect to this side and make circuit close. Circuit close means you can connecting to the another electricity source, for example, to lighting lamp in your home or in your house. So this mechanization is mechanical system. So it's very simple mechanization, just to pull this armature, this iron, to connect in the another side. But we don't need to push by our finger, but we push this armature, this iron, by using electromagnetic coil. So this position, minus and plus, it will be connecting to our microcontroller or our electronic development board that we already talking yesterday. So in one of the pin in microcontroller, it will connecting to this coil. So we can control this relay using IoT system. So we can control this switch from a long range distance or long distance. For example, you now you are located in Philippines. You can trigger this relay in our home, in our country, because we are using IoT system. You know, I hope you understand our explanation. So this is simple mechanization for a relay. The another type of relay, it is a solenoid valve. The difference between relay and solenoid valve is these solenoid valves driven by air, the high pressure air. So not electricity that will be connecting in here, but it is a high pressure air. Okay. So, for example, to open the electric valve, control valve, this actuator, it used the air pressure, not electricity. To make this move, to make this part move, we use the high pressure, the high air pressure. So it is one of the solenoid valve implementation. This is the mechanization. There are two sides. The air will be transferred here, and it will continuing to flow to the another side, but it's controlled by the solenoid valve. If the solenoid valve is open, this air will be transferred to the right side, and it will trigger the moving of this part. It's like you blowing using air. It's the mechanization, but how to trigger this part? We call it solenoid valve. It's also using coil electromagnetic, same with relay here. So we use the coil magnetic mechanization to pull the iron in the another side. In here also, this coil will be pull this part to move and open this gate. So we just give a signal, electric signal to here, and the coil will be work, and it will put this gate to open, and the air will be transferred to another sides. This is a solenoid valve. And electromagnetic valve, there are many electromagnetic valves. For example, is motor. There are three types of the motor. One is brush motor, the another is servo motor, the another is stepper motor. If we want to make some motion, for example, you want to make some mixing engine, you need this brush motor. Or you want to make some helicopter, some drone robot, or mobile robot, you can use one of this motor. You can control the speed of this motor. The servo motor is there are another type of the motor. It cannot to move 100 degree, because it just can move to 1 until 180 degree. So you need this type of the motor to open some mechanization. For example, you want to open the door or valve, or you can open this, or you can use this part to your robot. And the stepper motor is also, it is same with servo motor. The mechanization is same, so it cannot to travel move 360 degree, but it can move to 0 until 180 degree. So you can control the position of this move. For example, you want to move just 30 degree, or you want to just move 50 degree. It can be used, but you cannot use brush motor its case. So it has different function. Brush motor and servo motor or stepper motor. It has a different function and different structure. If you look inside this motor, they have a different mechanical structure because the function is different. So we have a three model. We have three model power to drive our actuator. One is drive by pneumatic, and the another is drive by electric. The another is drive by liquid. For example, this hydraulics. Hydraulics means the drive driven by liquid. We can see this type of machine. Let's say hydraulic is using liquid. For example, hydraulic for washing or washing car. It's hydraulic. It uses hydraulic power. It use liquid power. High pressure liquid power. It has big power, big energy than pneumatic system. So this it's normally used by heavy mechanization for lifting car, for lifting many type of the high the big things. The another is, for example, if you use the hydraulic, it has operating pressure range from 1 to 35 megapascal. It's a very high torque, high power. And the another is pneumatic system. It use air pressure. For example, many applications of this. For example, you want to make some mechanization, sim like that, to moving the arm or this automation device. Another. So there are many applications, there are many implementation of this pneumatic energy. Many of the industrial, they use pneumatic system for controlling, for moving many type of actuator. For example, for this, for pressure, some of the operation, for filling, for picking, and another type of the operational machine in industry. So how about the mechanization? Many of these systems, they use a solenoid valve. And the pressure, it's lower than hydraulic system. So you cannot use pneumatic to lifting the car. The energy, the power is about 10 Pascal or 10 PSI or 10 bar. Just is lower than hydraulic system. And the another source of the energy to drive the actuator is electric signal. We can use DC system or we use an AC system. So this is some of the example of the actuator that use electric signal. We call it electromechanical. So we use a motor here, and there are gearbox mechanization to drive this part. We call it a soft propeller. Electrohydraulic. There are also type of the motor, electrohydraulic, hydraulic that combined with electricity signal. So the power is from hydraulic, from liquid, but we use a solenoid valve to control open or close of our hydraulic motor, hydraulic system. And another source of the power of actuator is they use a thermal system. We can find this system in our refrigerator. I think every of you have a refrigerator. Refrigerators use this type of the actuator. We call it thermostat. Thermostat in refrigerator, they use mechanization of thermal source. It is the refrigerator. It is a thermostat in our refrigerator system. You can see here. We can setting our temperature, and refrigerator will be a monitor temperature because there are some liquid in this mechanization. It is there is some diaphragma in this side, and inside of this diaphragma there is some liquid like freon, like freon, and another type of the liquid that reactive to the difference of the temperature. So if the temperature is increased, the liquid will be response, and it will make this mechanization to increase, to move to the top, and it will be trigger the relay to run a compressor. And if the temperature is decreased, the liquid will be also response, and it will make this actuator to move down, and it will trigger the relay to close, to open, and the compressor will be off. So it is a thermal actuator that's very triggered by temperature. And another actuator is mechanical actuator. We can see here there is some gearbox mechanization. We use a gear in the set of rack and pinion. So how to choose the right actuator? Because of many types of the actuator, there are some actuator that driven by electricity. There are actuator that driven by air power, and driven by liquid. So how to choose the right actuator? So it's depend of our case. So it's depend of our problem. In this slide, there is some theory, some tips and tricks to choose the right actuator. The one is you need to consider the availability of resource. If there is no electricity in your area, you can choose the air power or the liquid power. But if you, for example, for mining industry, for oil refinery industry, it's a very dangerous industry that very sensitive with the electrical burn. Fire. It's very sensitive with fire. So if we choose the electric power, this is very high risk because if there is some mistake, there is some failure with this system, it will make some fire and make explosion. So in this case, in the many type of the oil refinery industry, they will prefer to use air source and liquid source. They will use a pneumatic and hydraulic system. because yeah, they need to consider the high risk condition. And the second is we need to choose and we need to consider how about the movement of our system. For example, we need to use linear, rotary, linear actuator or rotary actuator. So it depends of our system that we need to solving for this problem. And precision also we need to consider because many actuator also they have different precision specification. For example, if we use some mechanical or gearbox mechanization, we need to make sure that our actuator will be precision in our case. And safety and environment also it needs to consider. For example, if I already talking before, for many industry that sensitive with fire, for example, is oil refinery industry. It use many type of the pneumatic and hydraulic because it's more secure than use electricity signal. And for industrial case, there are some standard from the international organization that we need to fulfill the requirement from this association. So we need to comply. We need to comply. We need to adoption the rule from this organization to implement the IoT system or controlling system in industry. They have a regulation for this area. And the last is one of the example of actuator application in the SAM system. For example, in this machine coffee, there are many types of actuator here. Many of them is like control valve, piping control valve. So we need to open and close the pipe because we need to filling the bottle. So we need some of the type control valve. And the another is motor to mixing and many actuators that we will use in one of this machine. And smart door lock also is the many of product today. They use door lock. For example, we have the company in our country. They many selling this type of the smart door lock. So it use a relay actuator to open and close this gate. This also actuator, smart actuator. And the another is smart home light. You can use this actuator relay also. So many implementation of relay. So you need to learn what relay. For example, to lighting light off and on of our lamp in our smart home system. It also use a relay. Okay, this is our material for today. Maybe there's another. There are questions from a student. You have a question? Okay, don't forget to fill in the attendance list. I think you have the link, right? So sorry, I will posting again. Where's the link? Okay, it's the link for attending list. You can fill in the form, and if there is no question, I will close for this session. Thank you. We will meet again in the next week. Thank you for your attendance.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Bye bye.
Bye, sir.
Bye, sir. Thank you, sir.